Okay, so welcome to remote learning. I'm gonna try to get this video screen bigger so you can see what I'm building and everything. So, all right, I'll be small for now. Okay, so for this project, I'm going to show you what the project was going to be, what you were going to be introduced to, and possible answers to each build. So the whole point is this is supposed to introduce a decision matrix to you. So you would still do your design brief, but you'd also have to do a decision matrix. I'm toying with the idea of how to do that because you only need it if you're working in a group. And with our class size, we've been a little smaller, so a lot of this is individual. So we could always we wouldn't have you do, or I wouldn't have you do the decision matrix if you're working alone. So we won't even go into that. So the cool thing about this building challenge is that there are different tasks. So pretty much you can decide, hey, I want to do task 1 or task 2 or task 3 or 4. So what I'm going to show you today is what I would do to accommodate and meet the criteria for task 1. So it says the group needs to find a vehicle that will take them over rough terrain to search for people and to collect data. So the requirements, just these 3 requirements, are it needs to travel over rough terrain, it needs a universal joint, and it must be able to switch from 2-wheel drive to 4-wheel drive. So, meeting these ideas, I'll show you what I would do. You might not know what a universal joint is. I don't think we've worked with one yet. Universal joint is this piece. So you can put a shaft in one end and screw it in. And same thing with this. So now you can have, ultimately, it makes things very movable. So you'll see with what I built this car. You might notice that there's gears. So attached to the back wheel, there's a gear. And then I made this gear train all the way going to the front wheel. So if you remember, every gear next to each other spins the opposite way. So this would be spinning clockwise. So this is counterclockwise, clockwise, counterclockwise, clockwise. So first, third, and fifth will all spin together. So if you notice, as the back wheel is spinning, the front wheel is spinning because all these gears are attached. You'll see I have shaft collars really very tight on this end and this end. And that's why it's moving. So, so that at least the vehicle is moving now. But what you can also do is I made this shaft collar a little lower, so you can take that and just push it down. And now, when you spin the back wheel, the front wheel is not spinning because the gear train is out of sync. So this third gear isn't moving, which means that those gears aren't moving. So that's how to make it in 2-wheel. Then you just kind of pop the gear back in, and this is how you would then make it 4-wheel. So that's something to think about. And then as far as the universal joint is concerned, I just put it, you see, I have 12-inch shafts through the whole build, but this I actually made 6-inch shaft on one side and I screwed it into the universal joint, and then 6-inch on the other side as well. So the only thing that this helps do is it really, you can move the wheels around. So maybe if you're riding over rough terrain, you can, it can help keep the car safe. So something like that. So this is a good example of what you would build for the first task. So that's definitely an idea. So all I want you to do on Google Classroom is acknowledge that you watched this video, and the Google form will say, did you watch the video, yes or no? So you should click yes if you did. And then it's going to say, what number did Mr. White say during the video? And that number, so that answer is going to be 7. So in the multiple choice, when it comes down, you want to click 7, and then that's it. So this is what you would have built, or this is something similar to what you would have built. And I will show you something you could do for task 2 in the next couple days. So thanks for watching, everybody.